Alright guys, welcome back. Happy Friday the 13th. Today we're going to talk about only two challenging similarity problems. The first one is a little bit challenging. The second one is super challenging. Sometimes the question will ask you to prove. Sometimes the question will say you don't have to prove or you don't have to say anything at all. You can just use the similarity. But sometimes we're somewhere in between. Like in this case, you don't have to prove, but you actually need to claim the similarity. That means you actually have to write down which triangles you're actually looking at. Right? So for this case, we aren't actually given much information. We're only given the 4 and the 9 with the length. I'm going to use two methods to solve this problem. Let's start with the first method. Right, so the first method, what I'm going to do is WKP is similar to NKM. Okay, so I'm claiming that these two triangles are similar. That means not only that their side length, but also their height are proportional. So in this case, we're going to get A over B equals to 4 over 9. A from the smaller triangle, B from the bigger triangle, 4 again from the smaller triangle, 9 from the bigger triangle. So that's what we get. And if we cross multiply, we will get 9A equals to 4B. What I'm going to do now is I'm going to convert. I'm going to write everything in terms of A. So B equals to 9 over 4A. We'll use that later. Now the second thing that I'm going to do is I'm going to claim that triangle PKS is similar to triangle PMN. Of course, we can prove that, but in this case, we don't have to. If we know that these two triangles are similar, which I'm talking about the small one over here and the big one, okay, so P and M, you know what it is. If so, we're going to get A, which is one of the side lengths from the smaller triangle, compared to this A plus B, which is the side length of the bigger triangle. That ratio is equal to X, which is this, which is exactly what we're looking for, from the smaller triangle, to 9, which is a bigger triangle's side length. Now, what we can do is we can actually substitute our B into our equation. So what we're going to get is we're still going to get A on the top. But then A plus B now becomes A plus 9 over 4A. And that still equals to X over 9. And our equation will become A, so on the top, A plus 9 over 4A gives us 13 over 4A. And magically, our A actually cancels out. We don't actually have to worry about what A is. And that's equal to X over 9. You will get this 1 over 13 over 4 equals to X over 9. Well, you know what it is. This is actually equal to 4 over 13 on the left-hand side. And on the right-hand side, we still have X over 9. Okay, X is equal to 9 times 4 over 13, which is 36 over 13. And we are done. I want to show you guys the second method. I personally found this method very cool. So let's go ahead and take a look at it. Again, I will actually set this X. And not only that, I will set everything exactly the same. So I will have A over here and I have B over here, which means this is A and this is B. Okay, same thing. And then the first thing that I'm going to claim is that triangle PKS is similar to triangle PMN, which means this smaller triangle in the blue compared to the bigger one over here, they are similar. Of course, we can prove it, but in this case, we don't have to. And if that's the case, what we're going to get is A over A plus B equals to X over 9. Well, A from the smaller triangle side length right here. And if I compare that to the whole big length over here, that's going to be equal to X, which is the side length of the smaller triangle, compared to 9, which is the side length of the bigger triangle that we're looking at. So we'll keep that. We're actually not going to touch it. We're going to move on to the second similarity. So the second similarity is NKS is similar to NWP. What I'm talking about is this triangle, small triangle in the pink, compared to this bigger triangle over here, also marked in pink. In that case, I'm going to get B over A plus B equals to X over 4. So B from the smaller pink triangle compared to the whole A plus B, which is over here. And that is equal to X, again from the smaller triangle over here, over 4, the bigger triangle. The magic is if we actually add these two together. Okay, so what I'm going to do is I'm going to add these two. Left-hand side, add left-hand side. Right-hand side, add right-hand side. Okay, so what I'm going to get is A, on the left-hand side, okay, A over A plus B over A plus B. Okay, so this is my left-hand side. Okay, so these are my left-hand side. That is equal to my right-hand side. Okay, my right-hand side is going to be X over 9 plus X over 4, right? So left-hand side equals right-hand side. But magically, the left-hand side actually add up to 1, right? This is equal to A plus B over A plus B. Okay, common denominator A plus B. And all we need to do is just add the numerators. Okay, so but the numerators are just A plus B, simply. So we're going to get A plus B over A plus B, which is going to give us 1 later. That equals to X over 9 plus X over 4. This is equal to, if you use common denominator 36, we're going to get 4X plus 9X. Okay, that gives us 1 equals to 13X over 36. And the answer is X equals to 36 over 13. We arrive in exactly the same answer. I quite like this method over here because we actually didn't really need to do any conversion of A and B. We just solved for X out of a sudden. Now second and the final example. Pause the video if you like. You may like to try this example. But little warning over here, guys. This is a super duper hard example. So if you realize that it takes you more than 20 minutes and you still have no clue how to start, please come back and I'm going to provide a solution. Now, before we get started, I want to point out what exactly we're looking for. We're looking at the C, C1, C1, C2, C3, C4. What are they? They are C, C1 over here. C, C1 is a line segment from C to C1. Okay. C1, C2 is a line segment from C1 to C2. Right. C2, C3, same thing. C3, C4, and so on. Okay. So basically, we're finding the total length of this zigzag thing over here. Imagine it goes on forever. Okay. So let's mark down a few things. Let's say this over here is equal to 3. And then we have AC equals to 4 as given. And then we also have AB equals to 5. Good to go. First thing I want to claim that triangle BCC1 is similar to triangle BAC. Why is that? Because if you draw little triangles over here underneath, you're going to quickly realize that these two triangles are actually similar. First of all, both of them are right triangles, and all their corresponding angles are exactly the same. So I put it in this orientation so that you can see very easily which angle is corresponding to which angle. Okay, therefore, which side is corresponding to which side. Therefore, we're going to get 3 over 5 equals to CC1 over 4. Okay, 3 from the smaller triangle, 5 bigger side, the hypotenuse of the bigger triangle. And CC1, the bottom of the small triangle, compared to 4, the bottom of the bigger triangle. There you go. We made our first step forward. We got CC1 equals to 12 over 5. Okay, if you move the 4 to the other side. Okay, so that's the first thing. This is actually gold. We're going to use that to solve the rest of the problem. Now, I will need to make a second claim in order for us to see the pattern. I'm going to say that C1, C2, sounds very tongue twisting, is similar to triangle BCC1. Okay, so if you draw the little triangle underneath, you're going to see something like this. Okay, C1, C2, BCC1, all the corresponding angles and all the corresponding sides being shown. We know our C1 already, so we label it 12 over 5 over here. And we're going to find out what C1, C2 is. And according to this similarity, we're going to get the following ratio. Okay, so 12 over 5 from the smaller C1, C2 compared to the 3, which is the hypotenuse from the bigger triangle BCC1. This is equal to C1, C2, which is the bottom of the small triangle, over C1, which is the bottom of the bigger triangle. Okay, and therefore, finally, we can find our C1, C2. Our C1, C2 is equal to 12 over 5 times another 12 over 5 times a 1 over 3. But we can actually simplify that a little bit in order to find out the pattern. So 12 over 5 times 1 over 3, this is actually going to give us 4 over 5. And we're still going to have the 12 over 5 from the beginning. What does that mean? That basically means that your C1, C2 is basically 80% of your original CC1, which is 12 over 5. Right? If you keep going more, you will realize that pattern over here. You're going to realize that your C1, C1, C2, and C2, C3 are going to follow this pattern. Right? We're going to have 12 over 5 times 12 over 5 times 4 over 5, 12 over 5 times 4 over 5 times 4 over 5, and so on. Alright, so if we kind of mark them with different color coding over here, you will see that, for example, let's call these ones A, and let's call these ones over here R. Right, so the first one, you're going to get an A. Second one, you're going to get an AR. The third one, you're going to get an ARR, which is AR squared. How about that? Okay, basically what we're doing is we're adding AR squared, AR cube, and AR all the way to a very big number. Okay, how can we achieve that? Well, let's call this A plus AR squared plus AR cube, and so on. This is exactly what we're looking for. Let's call it S. Okay, we're going to solve for S. Right, now here's a fancy way of solving S. What we're going to do is we're going to multiply the whole S by R. Okay, once you multiply the whole thing by R, that means every single term will be multiplied by R. We're going to get AR plus AR squared plus AR cubed. This AR cubed becomes AR fourth, and we keep going on. Okay, and what is so good about this is when you do the subtraction in this case, right, when you do the left hand side minus the left hand side, right hand side minus the right hand side, what you're going to get is, on the left hand side is easy, S minus RS. Okay, nothing special. On the other side, you're going to see a lot of cancellations over here. Okay, you're going to see that, first of all, the AR and AR cancels out, AR square cancels out. They cancel out like this way, diagonally. Okay, someone is going to cancel out with my AR4, and then everybody else will eventually get canceled out. Okay, suppose that it goes on forever. So that means you're only going to left with A. And if you factor out the S from the left-hand side, you're going to get S times 1 minus R. This is equal to A. So basically, your S is just equal to A over 1 minus R. What is your A? Your A is 12 over 5. What is your R? Your R is 4 over 5. Okay, so 12 over 5 over 1 minus 4 over 5. This thing is going to give us 12 over 5 divided by 1 over 5. And the answer is going to be 12 over 5 times 5 over 1. 5 cancel out. The answer is going to be a beautiful number 12. Crazy, huh? But this question, it's not quite a fair game for your test, actually. But just the fact how similarity can trick people in a certain way, this could be actually a very good example. Okay. Today on your homework, you're going to see some other challenging problems. Those are actually the fair games on the test. So please work on them and see whether you can solve them. And that's it for today, guys. Happy weekend. I'll see you in the next lesson. Peace.